Hello, hello, hello. Oh, what's up, fam? Back at it again. April 30th, almost 1 p.m. at HKUST. Yeah, learn how to solve a bunch of like these graph problems. I haven't done the shortest path algorithms yet, like the Dijkstra's, the um, greedy algorithms. I haven't done any of that. Um, but I've found a couple of LeetCode questions for us to solve. Just regular graph questions. So yeah, let's do this one first. Um, yeah, so you return true if there's a valid path or false otherwise, right? So what I want to do first, um, because the edges is given in this, it's an edge list instead of an adjacent list. I'm going to turn it into an adjacent list, right? Um, so what I want to do first is probably write so equals to um, make, let's say it's this, right? Make a JSON list and it takes edges, and it should probably take oh. So what this function does is it should turn the edges vector into JSON list, okay, and then for vector of in edge in edges, what this does is is you would first create an unordered map. This, right? So res dot map media edge 0 back, right? Int, this would be an int with push back because it's a vector, you would push back edge, I mean, yeah, right? And then this would also happen vice versa because it's a bidirectional graph. So for every single edge, I push the edge into the map, and then the map will create a a um, adjacent list, sure. And then after you return graphs, right? Okay, so let's try this first. And then I wanted to return, wait, no, it takes n, so it should be of size, it should be of size singular what I want to do here is for um, smaller than is plus and then if res is not this is zero, meaning the count this in res um close to else it doesn't matter. And then the return res. I'll see that just a list is correct first. Just want to see what this gives. Right? And now I have a list. I want to want to reverse and it will In the base case would be if source something base case and then for or brother is the source. I would BFS this this returns true, then I would return true. Right? And then if what is the base case here? Source equals the destination, right? And I would return true. And if it's not, then I'll iterate through the neighbors the adjacency list, of course.
Hello, did you call me? Yeah, I would think so. Okay, continue. Did you see that?
I would also take a
Those are you all.
fact
Okay.
that is called visitors.
Doesn't matter. I'm working.
The source it's not the source, then I have to check if
No, I told you.
the thing is uh, visited for. If we ordered no, if visited dot contains source, and you don't need to go through it, and if it does not,
干嘛你干嘛？我都你九年。
then visited dot insert source, right?
No.
Push through it.
so much differently. But after next Wednesday, I'll be fine.
Source, destination. See this right.
I don't
Got it. Oh, I'm gonna see it.
I'm just going to treat and shop for the whole day.
Edges. DFS. Source.
It's just so messy. Yeah. The note doesn't change. Like that. Like I would not have noticed it if no one like pointed out like directly to me. Okay.
Visit that contains source and you return funds. It's only Wednesday. That won't make a difference. Oh, this exceeds I. Hmm, better way to do this. Mm-mm. What if I run this one first? That'll make a difference. I don't know. So I don't need this. Um, the logic is saying the logic is the same though. Being set, what's different? The world was ending. The logic is the exact same, but I just couldn't use a difference is I used a map and I used a set. They made it extremely slow, I guess. But I did get the logic though. Okay, cool. Let's have to return the common element of the first two now. For in in node in edges is 0, right? If node vector operations can I find that. By they lie. But right, yeah, I mean this is just a cheese one because like yeah, I mean it's a star. So I just find the common element within the first two element of edges, right? Yeah, yeah. If the first element, I can even further simplify it. Return if edges length 等于 edges 一 length or edges length 等于 edges 一 in that case you return length else return edges length right? Wow, beautiful. Okay, this one I need LeetCode Premium to access on LeetCode itself. So I'm just gonna do it on LeetCode, I guess. Unlogged in. There's an undirected graph of end nodes. There's also edges, numbers, return note total number of connected components in that graph. Right. Okay, I know how to do this. So I want a end nodes. So learning from the one that I did just now, I can simply do vector of int, right? Of There's the JCC list of size n, and then I can also have vector of Boolean. Uh, this is called visited of size n and 0, right? And false. And I'll have another function called DFS, which takes um, the amount nodes and then the adjacency list And then it takes, what else does it take? It traverses, right? If, what is the base case? The base case, I'll feed into it an adjacent list. Let's say I pass in like, because this is going to be for uh and right. Okay, so if, oh, and this also passes in the visited of vector goal, right? So if it has been seen before, it visited um it shouldn't be n, right? This should be current. If it's true, then you return false. If it has not been, then you set it to true. And here you let size equals to 1. Int size equals to 1, right? And then for what is an int? It's current, right? For int neighbor in the adjacency list of current, right? First, I have to turn this into an adjacency list. Uh, for vector of int edge in edges, right? Edge 0. First edge 0, top push back. I'll push this back to edge 1, and then this thing 1 will be 0, right? So now I have the adjacency list um, at each index, right? Okay, yep. And then here, visited equals to true in size 1 for each neighbor in the adjacency list of the current node, right? Mm-hmm. What I want to do is I want to, if DFS, the current would be neighbor, right? Return uh, I plus or equals to this because it returns an int. I've already visited that, go to the next neighbor. Right? So let's say I have not visited this node, and I will go into its neighbors. I'll add whatever they get. Uh, right? And I'll return size. Yep. No, why am I returning size? Am I even returning size? Okay. Total number of connected components, right? There should be some sort of count. And then for user return. Ooh. For every n, I think. DFS I adjacency list visited do this Is this right? Hello? Stop. I don't know where they went. Hello, hello, hello. Stop, stop, stop. Yeah. Huh? What? Huh? 我唔知佢去邊啊 She went with Sophie. Till 10 tonight, I think. Yeah. All right. Oh, no. Bye. No. Are you guys? Really? You're going out? Happy birthday. Bye. I will just simply traverse it, right? Done with all the neighbors, and then I'll return true. Done with all the neighbors, and then I'll return true. Right? I think. Is this right? Fuck. Something is wrong here, I believe. So I simply let it go. I just do this? Return bool, I guess. Doesn't matter. Current one I'm visiting isn't visited. And for every single one, I will traverse. Why is this wrong? And somewhere in here it went wrong, I believe. Not number of islands. What do this now? Thinking about it double counted? Adjacent list of current. Now your current will become a neighbor. Yeah, why is it wrong? Because I'm not properly updating the visited. Right? Yeah. Right. Okay. Because if I pass and visit like this, it's a copy. So I need the reference to actually like pass them by reference, so it actually modifies this visited for every single um pass that I'm passing it, every single iteration, everything that we talk. Um, that makes sense. It does make sense. It does make sense. It does make sense. And the adjacent list can be constant, I'm pretty sure, because I'm not changing anything. Okay, that's cool. That is very, very cool. So I don't think this was the problem, but let me sure. Yep. Okay, cool. Okay, and then now let's do number of islands. This is a completely different thing because now it is doing um, matrix thing. So it's completely different, right? Um, so what I want to do here is it has to be another DFS, right? Um, this is full, and then it would give in current, I believe. No, it would give in row, in column, um, a vector of what would the map look like? The map would look like thing. This would be the list, and then this would be a vector of bulls, right? We visited. What would that look like? Sharing the check. This So I guess you don't need but whatever. You don't need okay, so you do need the grid. Vector of char. Okay, so you do need the grid. The grid itself, you don't need to turn into an adjacency list. Okay, yeah, sure, that makes sense. And this would be a vector of bull. So, and this would have to be reference. And then vector of bull um, visited would have size n would be of size um, grid dot size, right? And so how do I initialize all of them to be false? Can I still do this? I wonder. Okay, and then if r is smaller than grid dot size, no, graph is, so it's the bounds check. Bounds check. If row is smaller than 0, could it be smaller than 0? It could be smaller than 0. Or R is bigger than grid dot size, bigger or equals grid dot size. I'll return false in this case. Or C is smaller than 0, or C is bigger or equals to the grid dot 0 dot size, right? Then, in this case, I would return false. So there's the bounds check. And then if visited dot row dot column is true, then I'll return false. And if it is not, then I'll set it to true because now it's visited. And then now I would like to for um for then I'll simply let it reverse. R minus 1 equals to going up, right? Up, down, to the left, to the right. I'll return true. Right? Now, equals to 0 for in I equals to 0, I is smaller than grid size plus I, or in J equals to 0, J is smaller than grid 0 dot size plus J, then I will, if BFS of I, J, grid, and visited returns true, then I will plus count. Else, after finally return count. Perhaps this is correct. Nope. Okay. Yep, this is wrong. Then I would assume it's something like something like this, maybe? Can I initialize like this? No. How to initialize vector of vector? Oh, okay. Visited. So visited would be grid dot size. Who would be grid dot 0 dot size plus. Maybe like this. Just make sure it's right. Grid dot first. The row, right? Count I, J. Mm-hmm. Plus plus count. Okay, and then let's go here. If R is smaller than 0, or if R is bigger equals to grid size, or does not make sense, or if C is smaller than 0, doesn't make sense, or if C is bigger or equals to size, or return false. Or this, or this, or this. Return false. Mm-hmm. But out of bounds. If visited is true, then I'll return false. Then I'll set it to true. then I will traverse up, I will traverse down, I will traverse left, I will traverse right. Grid stays the same, visited has changed. I don't know what's wrong. Um, yeah, I don't really know what's wrong. Right, I only want to count. I only want to count um if grid I j is equals to 1 and this, right? And I'll be right. No? Still wrong. Reverse. If it's water, then return false. Is this? Maybe? Right. Okay, I forgot this. Forgot this condition. Uh, okay, if it's equals to water, then I should return false. I should only count if it's land. Oh, fuck. That wouldn't be quicker. If grid I and j is equals to 1. Because if it's water, then I can skip it right straight up. So, still doesn't work. Why? So I shouldn't use a nested loop. Instead, what should I use? Mm. So I shouldn't do this? What are we saying? Equals to 1. There's some random thing. Is that what it's saying? I'm passing the grid. If it's out, it's not equals. If it is equal. I check, right? Boom. See it? If it is equals 1, then I'll set it to done. I've done it. And then up, down, left, right. And I'll mark it. Okay, genius. So I see a new island, then I will depth first and then mark all of them as whatever, right? I'll mark all of them as whatever. Um, no, go next, 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 next. Okay, yeah, that's very genius. Very, very genius. Very, very genius. Bonus. Oh, oh, you, you, I follow you, you see me going on. Oh, yeah. If it's out of bounds, return. If it's not equals to one, return. So if it is equals to one, you mark it, and then you go up and down, up and down, up and down, da, 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 da. Let's recursively increase. Go to the next. Tiếng một cầm to lên. Again, this is the problem. I have to recursively update the grid, just like how I'm doing with visited. Fine, understood. I get it. The logic is there. Execution is pretty poor. If, for example, I shouldn't use a vector of booleans. Instead, I should just update the grid by itself. Let's do this. I'll pass in, um, and I'll pass in the grid. Right? Let's just see if this works. If I do modify the grid, right, this has to return int. And then if r is smaller than grid dot dot size, or R is bigger equals to grid 0 dot size, or C is small. What am I doing? 0, 0, or C is larger equals to grid. No, what am I doing? Grid size 0 dot size. Then I would return 0. If it is in bounds, another base case would be if um, grid RC is equals to water, return 0, right? Else, and if it is land, or right, right, up, down, left, right. So then now it would be a problem of um, double counting. Right? So what I have to do, I can just modify the grid in place equals to -1. Right? So this will become is not equals to 1. There has to be some sort of max here. If if grid I grid J is equals to 1, then I would DFS. Right? DFS I J and grid. And then if size is this, if size bigger than max, then max would equal to size. Return max. If it equals to 1, then I'll come in here. And then I'll retrieve the size of the island. And I'll also modify the current shits, right? I feel out of something in the way you move. Jesus Christ, I'm sorry. A lot of typos. No? What's wrong? Equals to 1. I'll come in here, DFF. This will not be. This would not be. I will set this -1. Size will be equals to 1. Size r minus 1. Right, r minus 1 is outside. So, like that. Yeah. Let's try it. Oh my god, did it. Did it! It just did it. Yeah, so I set a max and then classic double nested loop because it's like this sort of island graph problem. If the grid is equals to 1, then I'll go into it and check the size of that island. And then what happens within this. And then if the size of that island is bigger than max, then I will set max the size and I'll return max, right? Easy. What happens within this function exactly? So what this function does, it takes a row index, a column index, and the grid itself, reference the grid itself, pass by reference instead of pass by copy, and then it checks if the indices are inbound, right? If it's out of bounds, then it will return 0, meaning like these columns, or this column, this row, this, it's outside of the grid, right? And if it is inside the grid, and if it's water, then it will also return, right? Or if it's a island that we've previously been to, which I will set to -1, then I'll also return, right? Um, and then if it is an island, then I will set it to -1, and then I'll make size equals to 1, and then now I start recursively call on its neighbors, right? So let's say I'm here, then after here it will become -1. I will check it's up, out of bounds, return 0. Check it's down, return 0. Left, return 0. Right, return 0. So now size will be equals to 1, then I return size, right? And size is bigger than 0. 1 is bigger than 0, so max is now 1. And I'll continue iterate, 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 and I'm here, right? Here I'll call DFS. It's inbound, it's equals to 1, so now this becomes -1, size becomes 1. and then I'll call it up, out of bounds returns 0, down. Um, Down is here, and then size equals to 1, then I call it up. Size, so this becomes -1 as well. Size becomes 1 here. I check up, returns 0, left returns 0, this returns 0. Here, this becomes 1, this becomes -1, up 0, down 0, left 0, right. Oh, right. Now I can DFS. This becomes -1, up 0, 0, 0, 0. So this becomes 1. This returns here, size becomes 2. This returns here, size becomes 3. This returns here, size becomes 4. Now I return to here. Size equals to 4. 4 is bigger than 1. The max becomes 4, right? Etc. 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 Until we get to this element. And then now return max. Yep. Pretty good. Pretty good. Pretty good. Yeah. I think I did pretty well there. So let's see if there are any other of these island questions that we can do. I have to be here until 10 tonight, which is kind of fun. Island perimeter. We're given a row representing the map where, okay, grid cells are connected horizontally or vertically. Grid is completely surrounded by water. Okay. Meaning the water inside isn't connected to the water around the island. What? Weird. I want to do this one though, the daily problem. Um, Given an array nums of integers, return how many of them contain an even number of digits. Nums and n is not 0 and whoa, divide by 10, right? get the number of digits here. If n digits So what I did here, the result is verse 0. So this tracks however many of them contains even number of digits. And then so I iterate through the numbers. So for each number, I create another variable called n digits, which tracks the number of digits it has. And then while the number is not 0, I divide it by 10. So it effectively just reduces one digit, right? So 34 divided by 10 is 30. 345 divided by 10 is 34. Because it's floor division, it drops the last digits. So 345 divided by 10 would be 34. And then plus the number of digits. 34 divided by 10 is 3 plus the number of digits. 3 divided by 10 equals 0 plus the number of digits. So it's 3 digits. And then n would be 0, right? And then if the amount of digits modulo 2 is equal to 0, meaning it's even, meaning there's one number increase that has even number amount of digits, right? So I return res. You've got all pretty basic stuff. Yep, exactly. Pretty chill stuff. Yeah, I'm gonna call it there. Um, and I'm going to learn about like Dijkstra's and other bullshit, I guess. Yeah, I have to learn the minimum spanning tree stuff, like Prim's algorithm, something like that. Yeah, so